All right, this is Chapter 1 on data collection. If you print the guided notes, this will follow those. You might also want to print the tables and formulas pages. There are 8 pages. You might just want to print them and kind of staple them together so you can always have them to refer to. The first page is formulas. Chapter 1 does not have any formulas. It starts in Chapter 2, so you don't need the first page right now. You might want to label it page 1 because I will refer to those page numbers throughout the videos. Page 2 is formulas. Page 3 is formulas. So again, I'm just numbering each page. Page 4 is formulas. We don't go that far in the textbook, so we won't even be using page 4. For Chapter 1, we are going to need the 5th page of the formula booklet. This random numbers table, table Roman numeral 1. And so we'll be referring to this later in the Chapter 1 videos, but you might want to have this printed. Just print all 8 pages now so you can have it throughout the course, and just number the pages so that you know which page I'm referring to. So have that handy. We'll refer to that later on in Chapter 1. So Chapter 1 is just an introduction to statistics. Really, it's just a lot of vocabulary that you might have heard before, but maybe not in a math classroom. And so we're going to kind of get familiar with the process of statistics, some key vocabulary, and what it looks like in a statistics environment, which is a little bit different than how you might have seen it before. So we're going to start with the process of statistics. Anytime you want to gather any sort of data, this is the process we go through, give or take a little differences, but most research follows this process. The first thing you want to do is identify the research objective. The first thing you want to do is decide on the question to be answered. What is it that you're trying to figure out? What question are you trying to have answered with your research? So that takes some time. You really have to look into what is it are you trying to research and how. And so decide on the question to be answered, and you also have to decide on the population to be studied. Are you going to study people, animals, objects? If you're going to study people, what kind of population? Women, men, young, old, by location? Who are you going to study? Who are you trying to collect this information on? Could be animals, could be objects, could be humans. So identifying the research objective is both of those tasks, deciding on the question to be answered along with the population to be studied. And then, once you know what you're trying to study and who you're trying to study, you collect the data. And so you have to use proper sampling techniques, which we'll talk about later on in Chapter 1. That's the most important part of collecting data, is to use proper sampling techniques. And we'll get, again, into that more when we collect our data. So using proper sampling techniques to collect your data. Once you've collected your data, you describe the data. This is summarizing the data. Sometimes this means getting an average, a percentage, all kinds of different ways we can summarize the data. And you can display the data. And it really is just to give an overview of the results. Kind of what kind of results did we get from our data. This will be discussed in chapters 2 through 4. And so collecting the data we're going to talk about here in Chapter 1. We don't really get into writing proper questions and deciding on populations to be studied. That's more at the graduate level. But we start with sampling techniques. Then we get into how do we describe our data, how do we summarize it, how do we make displays about what we've collected. And then the last part of the process is performing inference. And that is extending the results from a sample to a population. And there's a lot that goes into performing that inference. And so we're going to talk about reliability in chapters 5 through 8. And we're going to talk about actually doing inference, actually making predictions in chapters 9 through 10. It's actually the rest of the textbook, but we stop at chapter 10. So again, we start with proper sampling techniques. Then we learn all the different ways we can summarize data. And the second half of the course, units 3 and 4, is about extending our results from a sample to a population. And there's more details of all of this in your textbook. These is just kind of the main ideas of each phase in the process of statistics. So let's look at an example of how to break down this process. The example from your textbook is about minimum wage. It says that CBS News and the New York Times conducted a poll and asked, as you may know, the federal minimum wage is currently this. Do you favor or oppose raising the minimum wage to that? So the following statistical process allows the researchers to conduct their study. So we're going to figure out what is the research objective, what data do they collect, how do they describe the data, and perform the inference. So this is, again, all in your textbook, and I'm just going to kind of summarize and recap each phase of this process. So the first part is the research objective. So their question to be answered was to determine the percentage of adult Americans who favor increasing the minimum wage. That is what they're trying to figure out. What percentage of adult Americans favor increasing the minimum wage? So the population that they were studying, they specifically focused on adult Americans. So you have to be specific of who are you trying to study. In this case, it was adult Americans. They want to figure out the percentage who favor increasing the minimum wage. That is their focus. So then they collect their data. We cannot ask everyone, right? I cannot go door to door across the entire United States and ask everyone. So instead, we take a sample, and again, we'll get into sampling techniques later. So we take a sample. In this example, it looks like they surveyed 1,009 adult Americans and found 706 were in favor of the question of increasing the minimum wage. And again, all of this is in your textbook. I'm just kind of shorthanding what went on. So we cannot ask every single person, so they took a sample of 1,009 adult Americans and found that 706 of those 1,009 were in favor of increasing the minimum wage. So collecting the data takes some time, and we'll talk about proper and improper ways to collect that data. Once we've collected the data, we can describe our results. So of the 1,009 surveyed, they're saying that 70%, and they got that from 706 divided by 1,009. We'll talk about how to do that more later. 70% of them favor increasing the minimum wage. So you take your results, and you usually turn them into an average or a percentage, some sort of summary of your results. We'll talk more about displaying those results and interpreting those results later on. So we've asked our question, we've gathered our data, we've summarized our data, we've described it, and now we're going to make some predictions. And so to extend these results, And again, we'll talk about how to do all of that later. To extend these results, we must account for, they call it uncertainty, it's more variability. So even though our sample was 70%, there's no way to know if the population would also be 70%. So to account for variability, which is also sometimes called uncertainty, we give what we call a margin of error. We'll talk about that later on in Chapter 9. I call that kind of a cushion. In this example, there is a 3% margin of error. So when we perform inference, we can't be 100% confident in what we're doing. We have to give ourselves a little bit of buffer, a little bit of flex. And so we would say we are, usually it's 90 to 95% confident that the population, I'm going to run myself out of room here, the population percentage, given that our sample was 70%, we feel that the population percentage is somewhere between, and we would take 3% off of that and add 3% to that. So we could say between 67% and 73%. So our sample was 70. We give or take a little bit to give ourselves a little kind of a window of confidence, and I apologize for having to crush that into the bottom of the page. Again, all of this is explained in further detail in your textbook. I'm just kind of summarizing. So that is the process of statistics. Given any sort of scenario, we can break it down into the research objective, collecting data, describing the data we've collected, and finally performing inference. And again, this is a very long process. We will break down each step of it in the second half of the course. So let's move on to some vocabulary in the course. Again, these are words that you might have heard of before, but maybe not necessarily used in the same way as we're going to use them. What I've done is I've given you the definition for each word, and I'm just going to fill in the vocabulary term as we go along, and I'll kind of explain how each word works as we go. So the first word here is statistics, the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, this science provides a measure of confidence in any of your conclusions. So this is the whole process of statistics. We collect the data, we organize the data, we summarize the data, and finally we analyze the data. That entire process is statistics. So that's kind of the field of statistics. If you want to become a statistician, those are all the things you're going to do. More specifically, the entire group to be studied is referred to as the population. We've seen that term before, the population, everyone to be studied. A person or object that is a member of the population to be studied, we call an individual. So within a population, there are individuals. And a subset of the population that is being studied is called a sample. So we have everybody, we have each individual person, and from that population we draw a sample. So the entire group to be studied is the population. Individual is just one person in that population, and we focus our energy on samples in this class, a portion of the population that represents the population. Then we have the word statistic. So it's a singular statistic. So a statistic is a numerical summary from a sample. So if I took a sample and got an average, that average would be called a statistic. And then I'm going to skip down here. Going with statistic is the word parameter. So you have a numerical summary of a sample and a numerical summary of a population. If I have a numerical summary for an entire population, I call it a parameter. If I have a numerical summary for a sample, I call it a statistic. So there's statistics and there's parameters, and we'll talk about the differences between those two in the next video. Underneath statistic, we have organizing and summarizing data through numerical summaries, tables, and graphs. That whole process of organizing and summarizing data is called descriptive statistics. When we're describing the data, we could describe the data with tables and charts. We could describe the data with percentages, all kinds of different ways to describe the data. So it's called descriptive statistics if we're organizing and summarizing the data. And then if we're taking the results from a sample and extending it to the population, that is called inferential statistics. So inferential meaning inferring or predicting what might happen. So taking our results from a sample and extending it to a population is the process of inferential statistics. So there's descriptive statistics and inferential statistics. And so these words kind of go in sets. You notice I'm kind of changing colors as we kind of change sets of words here. They're kind of all grouped together. In your book, again, we'll kind of group them and give you further examples as we go along. The next word says the characteristics of the individuals within the population. So the characteristics of individuals, we call those variables in this class. So if you've taken an algebra class, variables are very different than the variables we're referring to here. So the variables are just describing the characteristics of individuals. It could be shape, color, size, GPA, income level. It could be all kinds of variables that we're studying. And there's two different kinds of variables that we're going to look at. The first kind is called a qualitative variable. Qualitative variable looks for a classification of the individuals based on some characteristic. Qualitative, you kind of think of the word quality. And so this could be favorite color. It could be rank. It could be like junior, senior, sophomore, freshman sort of ranking. So it can be any sort of classification where you would put people in different categories. So this is sometimes referred to as a categorical variable. You put people in different categories, or animals or objects in different categories. Then there's also what we call a quantitative variable. And you'll see the word quantity, quantitative. So this is a numerical measure of individuals where you can add or subtract or average the results. This could be height. This could be weight. It could be number of courses completed or taken, or anything that you would measure or count is quantitative. This is a numerical variable. So if you put things into categories or classify them, it's qualitative. If you count things up and how many of this and how many of that, and can average them or measure someone's height, that would be a numerical measure, and that's called quantitative. So there's qualitative variables and quantitative variables, and we'll practice classifying those in the next video. Within quantitative variables, there are two specific types. There's a quantitative variable that has a finite number of possible values, and this is called a discrete quantitative variable. This is countable. If I wanted to know how many classes you were taking, how many siblings you had, how many cars you've owned, anything I could count, how many of this, how many of that. Anything countable is called discrete. And then a quantitative variable that has an infinite number of possible values that are not countable. This is more of a measurement. How tall are you? How much do you weigh? A volume of something. That is called a continuous quantitative variable, and that's a measurement as opposed to counting. So within quantitative, there are discrete and there are continuous variables, and we'll get into the difference between those two in the next video. I'm going to stop there, and then I'll continue in the next video.